Well, good morning or afternoon, whatever suits you. This is Mr. Dawkins' AP Chemistry and Advanced Chemistry channel. First, want to throw a shout out to sciencenotes.org. They have fantastic free periodic tables with great graphics as well. Pulled that from their site. Go check them out. They're amazing. We're going to talk about metric prefixes today and how to convert between one another. And we're also going to go over the quiz that we took a couple days ago on Schoology. So let's get started. Which conversions, which prefixes are we actually going to use in this class? Well, the ones that we're going to see most frequently are going to be kilo and milli. That is the most frequently asked. And because kilo, typically kilograms, is a common unit for measurement. It's the SI unit for mass. Milliliters we commonly measure in lab quantities. Now, you're also responsible for hecto, deca, deci, and centi. Why these? Because they make your life a lot easier when we're jumping by powers of 10, which is the title of this image. And then we're also going to throw in, there's a big jump from kilo to mega, so be careful there. And also milli to micro. That goes from 1,000, not to 10,000, but goes from 1,000 to 1,000,000, either times smaller or times bigger. Now, remember that in the very center, we have our base unit, okay? Base units go in the center. This is without prefixes. Meters, liters, grams, seconds, candelas, you name it. So let's go ahead and work the quiz and see if we can figure out some of this together. All right, first question. What we're doing is converting. It says we're converting 7.56 times 10 to the 6th meters, and we want to know how many capital M, lowercase m, that's megameters, that's big M. And what we're going to do is look at our conversion table, or we have it memorized, and we're going to know that there's 1,000,000 meters in a megameter, 10 to the 6th. So I'm just going to write 10 to the 6th meters in one huge megameter. Common mistake, students flip that. They say that there's 1,000,000 megameters in 1 meter, but that doesn't make any sense. Okay, we could punch this into a calculator and actually solve, but instead we have a shortcut. What we know is that when we are multiplying or dividing by scientific notation, specifically in this case dividing, we can subtract the exponent. So 6 minus 6 is 0. So it would be 7.56 times 10 to the 0, which that just goes to 1. So the final answer here is 7.56, and that's it. You could write times 10 to the 0, but it's not really proper. Okay, I'd say pause the video, see if you can work the next one out, and do that before I move on to each problem. This would be a great way to practice. Okay, let's do the next one. 55 nanometers. And we want to know how many meters that is. Well, nanometers are tiny, and if I look at my conversion chart, there are 10 to the 9th nanometers in every 1 meter. Now this 1 meter is the bigger unit, so it gets the 1. 9 nanometers is really, really small. Now there's another way of writing it. Let's show you. We could also say that 55 nanometers, we could say that in 1 nanometer, there's 10 to the negative 9th. So that's also possible. But to show you a way that we can use the shortcut, I'm going to go ahead and rewrite this whole thing. And I'm going to change the 55 to 5.5 times 10 to the 1. So I moved the decimal over, I turned it into scientific notation, and this is going to allow me to use that shortcut. So again, pick either one. I like to keep my exponents positive. 10 to the 9th small nanometers is 1 huge meter comparatively. I can stop there. I can calculate. Well, I have nothing to multiply on top, so I'm not adding any exponents. But what I am doing is going to subtract 1 minus 9. And 1 minus 9 would be negative 8. So I have 10 to the negative 8. And my coefficient's not going to change, so it's going to be 5.5 times 10 to the negative 8th. Okay, next one. I'm going to go ahead and convert to 4.25 times 10 to the negative 1 meters. And I want to know how many micrometers, what we call micrometers. So in this case, I know that in every 1 meter, I have 10 to the 6th little tiny micrometers. Now this case, I'm multiplying on top, so I'm going to add the exponents. I'll show that in a green color. So negative 1 plus 6 should give me a power of 10 to the 5th. So my final answer here would be 4.25 times 10 to the 5th micrometers or micrometer. Okay, next we're starting out with 5.0 megameters, and if this helps you, this would be times 10 to the 0. It's hidden, we don't see it, but if that helps you with the shortcut, then go for it. Okay, megameters, we're looking for meters. I know that in 1 megameter, has to cancel out, top and bottom, is 10 to the 6th meters. So I'm going to add, because we're multiplying on top, 0 plus 6. 0 plus 6 is 6, so that's 10 to the 6th. Final answer, 5.0 times 10 to the 6th. You notice I kept that trailing 0. I'm going to keep any significant digits in my final measurement. So 5 times 10 to the 6th is not correct. Okay, I want to show you how to work out the next one without using any sort of scientific notation. So 22 centimeters. If you were to leave it, which is fine, I'm going to look at my powers of 10 chart. I know that there are 100 centimeters in every 1 meter. So you'll notice that I didn't write it out in scientific notation. In this case, I'm going to be dividing by 100. So you could do that in your calculator. Shortcut would be to move the decimal to the left twice. So the answer is 0.22 centimeters. Now, 0.22, if I went ahead and turned that back into scientific notation, so again, 0.22, excuse me, that's 0.22 meters, not centimeters. If I put that back into scientific notation, it would be 2.2 times 10 to the negative 1 meters. I'll go ahead and show you the other way, just so you can see. I'm going to change this to 2.2 times 10 to the 1 centimeters. There's 10 to the 2nd centimeters in every 1 meter. So you can see I'm subtracting 1 minus 2 would give me that negative 1 exponent. So 2.2 times 10 to the negative 1 meters. I'm going to change 2.14 times 10 to the negative 1 meters. And I want to know how many nanometers that is. And I know that in every 1 large meter, I have 10 to the 9th small, tiny nanometers. Well, here we are multiplying these two, so I'm going to do negative 1 plus 9, and that's going to give me 8. So final answer, 2.14 times 10 to the 8th nanometers. Let's do the next one, 4.32 millimeters, and we are trying to figure out, excuse me, I need to fix that, don't I? That's 4.32 times 10 to the 2 millimeters. And you could go, if you know that there are 1,000 micrometers in 1 millimeter, that's great. But I'm going to work it out in 2 steps so you can see how this goes. I know that there are 10 to the 3rd millimeters in every 1 meter. I go back to the base unit. And then what I do is I can say that I know for certain that in 1 meter, I have 10 to the 6th micrometers. And you'll see that if you actually look at those exponents, that is a factor of 1,000, like we said before. Jumps an exponent of 3. But either way, what we can do is the same. So I'm going to add all the exponents on top. 2 plus 6. 2 plus 6 equals 8. And then I'm going to subtract by the exponent on bottom. So I should end up with an exponent of 5. So that should be 4.32 times 10 to the 5th micrometers. Let's keep going and do the next one. Same thing, 4.32, excuse me, it should be times 10 to the 2 millimeters. And then this one, same thing. I could go from millimeters back to meters and then to nanometers, but I'm going to show you the quick and easy way. I know that if I have millimeters to nano, that's going to be a difference of 10 to the 6th, which is a million. So there's a million millimeters, million nanometers in 1 millimeter. So I know that if I have 1 millimeter, that is going to house 10 to the 6th nanometers. So I used the shortcut there. Now, 2 plus 6, we're going to add the exponents. That's going to give us 8. So 4.32 times 10 to the 8th. And you'll notice right here, there is a difference of 1,000. And if you look at our chart, micro is 1,000 times smaller, or 1,000 times bigger than a nanometer. So this does make sense. Okay, 7.25, I'm going to keep that 0, times 10 to the 3rd meters. And I want to know how many kilometers that is. So I know that I have 10 to the 3rd meters that fit in 1 huge kilometer. 2 minus 3 equals -1. So I have 7.250 times 10 to the -1 kilometers. And let's finish it off here. 7.2 times 10 to the 8th nanometers. And I want to know how many centimeters this is. And I'm going to go ahead and bust this up into 2 steps. I know that there are 10 to the 9th nanometers in every 1 meter. And then I also know that in every 1 meter, there are 100 centimeters, or that's 10 to the 2nd. So 8 plus 2 equals 10. 10 minus 9 gives me 1. 7.2 times 10 to the 1. Now you could say that 72, also acceptable, but remember, we're just keeping things consistent here for the sake of the video. And again, if I went back up to the top, technically I could write times 10 to the 0, but that is unnecessary. Okay, y'all have a great day.